So in today's class, we will get started with definite integrals, important SAQ. So take the first SAQ, evaluate integral 0 to 4 x square by 1 plus x dx. So let's see how to solve this. Integral 0 to 4 x square by 1 plus x dx. So now what we will do is, we will add and subtract 1 in the numerator. So x square minus 1 plus 1 by 1 plus x dx. So here we are adding and subtracting 1 in the numerator. Now we are separating it 0 to 4, x square minus 1 by x plus 1 dx plus integral 0 to 4 1 by 1 plus x dx. Now how can I split the first term of the first term? X square minus 1 we can write it as x plus 1 into x minus 1 by x plus 1 dx plus integral 0 to 4 1 by 1 plus x dx. Now x plus 1 will get cancelled. Integral 0 to 4 x minus 1 dx plus integral 0 to 4 1 by 1 plus x dx. Now what is integral x dx? It is x square by 2 minus what is integral 1 dx? It is x. Once you integrate, you apply the limit 0 to 4. And 1 by 1 plus x integral is log mod 1 plus x from 0 to 4. So this is the way we apply the limits. Now you see how I am applying the limits. So x square by 2 minus x. In the place of x, I will put 4 first. So 4 square by 2 minus 4. First you apply upper limit, then put a minus sign, and then you apply lower limit. 0 square by 2 minus 0 plus. Now first x you put as 4. So you will get log 1 plus 4 is 5 minus log 1 plus 0 is 1. So now you simplify this. 16 by 2 is 8. 8 minus 4 minus this is 0 plus log 5 minus log 1 is 0. So finally you will get 4 plus log 5. This is the answer. And always remember, answer for the definite integrals will always be a constant. Now take the next question. This question is very, very important. It last appeared 2-3 times recently. That is in TS June 23, TS May 22, AP May 22. So first let us write the given expression, given integral. Integral 0 to pi root over 2 plus 2 cos theta d theta. That is integral 0 to pi. Now within the square root, I will take 2 common. So if I take 2 common, we will get 1 plus cos theta d theta. That is integral 0 to pi. Now 2 if I bring out, you will get root 2 into root 1 plus cos theta d theta. Now root 2 is a constant, so I take root 2 outside the integral. Integral 0 to pi root over. From trigonometry, we know that 1 plus cos theta is 2 cos square theta by 2 d theta. Now from this square root, again you have one more 2. So that 2 if I bring out, it will become root 2. So one root 2 is already there, one more root 2 comes out. So you are left over with root over cos square theta by 2 d theta. Now square and root get cancelled. Root 2 into root 2 becomes 2. Integral 0 to pi cos theta by 2. d theta. Now we know that integral cos theta is minus sin theta. So that is minus sin theta by 2 by 1 by 2. Now 1 by 2 if I take up, then after integrating we apply the limit 0 to pi. Now if I take this 1 by 2 up, it will become 2. So already 2 is outside. This 1 by 2 comes up and it becomes 2. And minus also comes outside. Now in the place of theta, first you apply pi, then we apply 0. So this is sine pi by 2 minus sine 0. Minus 4 into sine 90 is 1 and sine 0 is 0. So the answer is minus 4.
Yes, ma'am.
One minute. Here cos integral is plus sine theta. So you get a plus over here. So the final answer is plus 4. Now take the next question. This question last appeared in TS March 23. So let us write the given integral 2 to 3 2x by 1 plus x square dx. So this problem will do it by substitution method. So you put 1 plus x square is equal to t. And if we differentiate, we will get 2x dx is equal to dt. So whenever we are doing any substitution, its limit also changes. So if we are taking upper limit, how will the upper limit change? Put x is equal to 3. So t will become 1 plus 3 square, it will become 10. And how about lower limit? X is equal to 2. If x is equal to 2, t will be 5. Now, how the question transforms, you just see. Integral 2 to 3 will become 5 to 10. 2x dx by 1 plus x square. Now integral 5 to 10, 2x dx can be written as dt by 1 plus x square can be written as t. So 1 by t dt is log mod t. Apply the limits 5 to 10. So that is log 10 minus log 5. We know that log a minus log b is log a by b. So that is log 10 by 5. 5 ones are 5 twos are, that is log 2. Log 2 is the answer. Now take the next question. It last appeared in TS March 24 and AP May 23. Very, very important. First, let us write the given integral 0 to 1 x square by x square plus 1 dx. Now in the denominator you have x plus 1, but in the numerator you have only x square. So what idea is striking my mind is I can add and subtract 1 in the numerator. So adding and subtracting 1 in the numerator. So that will become 0 to 1 x square plus 1 minus 1 by x square plus 1 dx. Now let us separate it 0 to 1 x square plus 1 by x square plus 1 dx minus integral 0 to 1 1 by x square plus 1 dx. Now here x square plus 1 get cancelled and you will be left over with integral 0 to 1 1 dx minus integral 0 to 1 1 by 1 plus x square dx. Now we know that integral 1 dx is x. Apply the limits. Minus integral 1 by 1 plus x square is tan inverse x. Again apply the limit 0 to 1. Now first apply the upper limit minus lower limit. Upper limit is 1 minus lower limit is 0. Minus, here upper limit is tan inverse 1 minus lower limit is tan inverse 0. So this is 1 minus tan inverse 1 is 45 because at tan 45 value is 1 and tan 0 value is 0. That's why tan inverse 0 is 0. So the answer is 1 minus pi by 4.
Yes, ma'am.
Now take the next question. Integral 0 to 3 x by root over x square plus 16. So first let us write down the given integral 0 to 3 x by root over x square plus 16 dx. Now let us put root over x square plus 16 as t. So if we square on both sides, we get x square plus 16 is equal to t square. Now let us differentiate it. So we get 2x dx is equal to 2t dt. 2 get cancelled. So you will get x dx is equal to t dt. Now whenever we are doing any substitution, its lower limit and upper limit will change. So what happens to the lower limit? If x is 0, then what will be t? If x is 0, then t will be root over 0 plus 16 is root 16. Root 16 is 4. So t is 4. And how about the upper limit? Upper limit, if x is equal to 3, then 3 square is 9. 9 plus 16 is 25. And root 25 will become 5. So t will become 5. So now the integral will change from 0 to 3 to 4 to 5. Now it becomes 4 to 5. Now x dx can be written as t dt by root x square plus 16 can be written as t. Now t get cancelled. You will get integral 4 to 5 1 dt. Now 1 dt integral is t from 4 to 5. Now apply the limit. 5 minus 4 that is equal to 1. This is the answer. Now take this question. This is also important. First, let us write the question 0 to a dx by x square plus a square. So we have a formula. Integral 1 by x square plus a square dx is 1 by a tan inverse x by a plus c. This is the formula from integration. Now here the question is given in the standard form. So directly we can apply the formula 1 by a tan inverse x by a from 0 to a. That is 1 by a tan inverse a by a minus tan inverse 0 by a. A cancel. That is 1 by a tan inverse 1 minus tan inverse 0. So that is 1 by a tan inverse 1 is pi by 4 minus tan inverse 0 is 0. So that is equal to pi by 4a. This is the final answer.
Yes.
Now take this question. Find integral 0 to 2 root over 4 minus x square. So first let us write the given integral 0 to 2 root over 4 minus x square dx. Now see 4 can be written as 2 square minus x square dx. Now we have a formula integral root over a square minus x square dx is equal to x by 2 root over a square minus x square plus a square by 2 sine inverse x by a plus c. This is the formula for root over a square minus x square from integration. Now with limits we have to apply. So that is equal to x by 2 root over 4 minus x square plus a is 2 here. So a square will be 4. 4 by 2 sine inverse x by, in the place of a we write 2. So that is x by 2 and over here we have to apply the limits 0 to 2. So x by 2 root over 4 minus x square plus 2 sine inverse x by 2 from 0 to 2. Now first we apply the upper limit. 2 by 2 root over 4 minus 2 square is 4 plus 2 sine inverse 2 by 2. Here I applied the upper limit. Minus, now we have to apply the lower limit. 0 by 2 root over 4 minus 0 square plus 2 sine inverse 0 by 2. Now you see 4 minus 4 will become 0. So this term will become 0. 2 ones are 2 ones are. And here 0 by 2. So this term will become 0. So that is 2 sine inverse 1 minus 2 sine inverse 0. So 2 sine inverse 1 is 90 because sine 90 is 1 and sine inverse 0 is 0. So this is 2 into 0. 2 to cancel. Answer is pi minus 0, that is equal to pi.
Yes, ma'am.
Now take the next question. Evaluate integral 0 to 1 dx by root over 3 minus 2x. So first let us take the question 0 to 1 dx by root over 3 minus 2x. Again we need to use substitution method here. So put root over 3 minus 2x is equal to t. So if you square on both sides you will get 3 minus 2x is equal to t square. Now differentiating with respect to x you will get minus 2 dx is equal to 2t dt. So 2 get cancelled. Dx is equal to minus t dt. Now whenever we do any substitution, limits also changes. So lower limit will be x is equal to 0. So t will be root 3. And if x is equal to 1, then t will be 1. Now the integration will change from root 3 to 1. In the place of dx, we will write minus t dt by t. Tt get cancelled. That is minus integral root 3 to 1 dt. Now apply the limits. First you write upper limit minus lower limit. If you take this minus inside, you will get root 3 minus 1. This is the answer.